Hello and welcome to another video. In this video we're going to be working on open the lock. And you have a lock in front of you with circular wheels. Each number has 10 slots and the wheel can rotate up and down. So just like a basic lock, like imagine you have a number, like let's say with 0, you can go up to a 1, 2, 3 and so on. Or you can go down to 9, 8, 7, so it kind of like wraps around. So up increases, down increases, let's say, and you start out with 0, 0, 0, 0. And you have dead ends. So if you get to any one of these combinations, then your lock stops working. And you want to get to a target and you want to return what's the fastest way to get there. And you only have 4 dials, so there's only like 999 combinations. And how do you do it? So essentially, let's say we had no dead ends. Like let's just say we had 0, 0, 0, 0. And we were trying to get to, let's actually do this. And let's say we're trying to get to like some random number like this. So this one's pretty easy, right? And if you can't think of this one, like this should be pretty intuitive. Like let's say you have no dead ends. How do you do this? This should be pretty fast. Basically, you can just greedily turn each dial to what you need it to be. And you need to figure out like, is it faster if I go up or down? So from 0, you'd want to go to 1, 2, 3, which is 3. Then here you want to go down to 8, so you'd actually want to go down. It's going to be faster, right? So you go 9, 8. Then you go 1, 2, 3, 4 is going to be the fastest. And then 9, 8, 7. So altogether it says 3, 4, 5, 6, 7, 8, 9, 12. So that's how you would do it without dead ends. But with the dead ends, you can't just do the greedy of like, let me just make the number go to what I want. Because it's going to be very easy to hit a dead end and then kind of like not know what to do after that. Like you can try it, but basically you can't just do that. So instead, the approach we're going to take is for every single combination, we are just going to figure out like what combinations can it make. And then we can actually just make a function that will get this combination and then the combinations it can make. So if you think about it, like one move is just rotating one of these wheels by 1. So what are the combinations it can make? Well, it can make 1, 0, 0, 0, 9, 0, 0, 0, 1, 0, 1, 0, 0, 0, 9, 0, 0, 0, 0, 1, 0, 0, 0, 9, 0, 0, 0, 0, 1, 0, 0, 0, 9. Right, essentially, you can turn one of these things up 1 or down 1, and these are all the combinations it can make. And any number is like that, so you can plug in any number here, and you'll get 8 combinations. So we can make a function to get all those. That's pretty straightforward, and it's basically a 1 because this is only length 4. So once we have that, then imagine like this is kind of like a graph where you can go from this to all of these, right? So then it's basically just you have a source, which is 0, 0, 0, 0. You have a destination, which is target. So let's say like this is target. Then for every single node you're at, you just print out the 8 places I can go, and then you just check like, have I been here before? If I have, I don't need those, and then the rest of it is like a graph, right? So literally we just start with a graph, and then whenever we get to something we visited or something in the dead ends, we stop. So we can actually combine dead ends and visited and just use those together. So let's say these are dead ends. If we start at 0, there's never going to be like an optimal solution that starts at 0, goes to X, let's call it, and then goes back to 0, and then goes to target. Like that wouldn't make any sense. So whenever we visit something, we can just put it in the dead ends. And then we just do a basic BFS where we keep track of the number of moves we made and our current combination. And then whichever one gets us first wins. So just pretty straightforward BFS. So let's do that. And then I'll talk about a bunch of code stuff you can do in Java specifically. So in like Python or something, you would have a queue, and then your type in your queue would be like an array or a tuple where you have like an int string, right? And an int for number of moves, and then a string for your combination. You can't do that in Java. You can make like a list. I believe it's like you can make a list of type object, which will give you a dynamic list, because I think object can be like int or integer or character or string or anything. But another way you could do it is you can actually just make a generic tuple class of however long you need it to be. So we can actually just say class tuple, or we'll call it pair in this case because we only have 2 values, but you can make it as long as you want. And you can give it generic types if you want, which I'll show you how to do. for this problem, you obviously don't need it, but let's say you want to give it generic types, right? So you want a tuple where they can pass in two things, or a pair, they can pass in two things. And I think this is how it works in C++. You can have a generic pair of types. So let's say our types will have type K and type V. And then we can say, so type K. So you can either give this like literally K first and then V second if you want to, if these are your variables, but I'm going to call it the variables I'm going to use here. So I'm going to say K is going to be the moves, and V is going to be the combination. And then we just make a constructor. So we say public pair. I believe you have to do KV here. I think. And then you just say, or actually no, I think it's like this. So you give it public pair, and then you give it the two things that you pass in. So you can say like K moves, V combination. So this will be a constructor. It'll take in these two things, and now we can say this moves equals moves. This combination equals combination. So essentially, we make a constructor. It'll take two different things. You can call these generic if you want. You can literally say like first, second, and so on. You can also make this pair like a triple or whatever you want. But this is how you make a pair of custom types. And now we can use this. So now we can make our BFS. So we can use a DQ. And it will be, in this DQ, it will have these pairs. And in these pairs, we will have an integer for the moves. And we'll have a string for the combination. So like this. And then we will have our dead ends. And so what we want to do is we want to take these dead ends and convert it into a set and just put them in our visited set. So we can say set string visited equals new hash set. And so what you can do is you can take your array of dead ends, and I think you need to convert it into a list, and then you can pass it into the constructor for the set. Or you can loop through your dead ends and put them into the set manually. So to convert into a list, you just do arrays as list, and then this is going to be dead ends, and this is uppercase. Okay, sure. Let's see. Oh, this shouldn't be arrayed list. This should be arrayed deck, and there should be a semicolon here. So now our visited set will be our dead ends, and then now we can just do our normal BFS. There's also an edge case where if your 0, 0, 0, 0 is in the dead ends, right? If your starting string is in the dead ends, that can happen. So we can check for that. So we can say if visited contains 0, 0, 0, 0, just return -1 because we can't do anything there. So yeah. That one is fine. Now we can do our normal BFS. So we can say BFS add new pair, and the pair will be type integer string, and it will be 0 moves and our starting location. And we can add this to visited, and this is because whenever you have a BFS, your values that were further to the left are always going to be popped first. So if I already have something, like let's say I get to like 2 moves and some number like this, if it's already in my BFS, I don't need to ever put it in again because this will get popped first. So I don't need to put it in like somewhere down the road, like whatever, 15 moves. You know, like this, you don't need to do this because this will always get popped first. So this will always be better. So with a BFS, you can just mark it as visited as soon as you put it into the queue. So we can add this here. And now we just do a basic BFS traversal. So while BFS is empty. So we get our current item, so we can say pair integer string item equals BFS. So the one to pop from the front is pull first. So that's what we want. And if item, so this is going to be item, in this case, moves. No, item combination equals target, then we can return moves. Right, so, or this should be item moves. Okay. Otherwise, so we're going to make another helper function that's going to take our combination and give us our 8 combinations. So let's do that next. So we're going to have private, it'll return a list of strings. We can make an array if you want, it doesn't really matter. But I'll do a list of strings. And then we can call this like combinations or something. And it will take a string combination. So essentially for every combination, like let's say we have 0, 0, 0, 0, we just take each one of these numbers and either make it go up 1 or down 1, and then the rest stay the same, and those are 8 combinations. So that's what we're going to do. So we're going to loop through 4, and we are going to first get the number, first get like the actual number at this location, and then make it go up or down, and then make the string. So we can say int cur equals combination character at I. And so if you get something here, like let's say this character is 0, if you just convert this to an integer, you actually won't get 0. You'll get the ASCII value for 0. So in order to turn it into a 0, you basically have to subtract the ASCII value for 0. So what will happen here is, like, let's say that this value is like 50, then you'll get 50 minus 50, you'll get 0. And let's say this is like 6, you'll get 56, and then you'll subtract 50 and you'll get 6. So we have to convert this into an integer and then subtract the ASCII value for 0, because that's like our smallest number that we have. And that will make everything actually line up with like 0 to 9. Then we're going to make the making the number go up 1 and go down 1, right? So if we have a 0, up will go to 1, down will go to 9. So we can say int bigger equals, so basically all this is just cur plus 1 mod 10. So if it's 0, go to 1, if it's 1, it goes to 2, 2 goes to 3, and then 9 goes to 0. So we can just do this to handle that one. And then smaller will be kind of the other way, except we need 0 to go to 9, right? So like 9 will go to 8, 8 will go to 7, 7 will go to whatever, and then 0 goes to 9. So we can just check for that. So we can say cur equals 0. If it is, then it will go to 9. Otherwise, just do cur minus 1. So now we have like our 2 combinations, and we basically need to add these to our result. We also need to initialize our result. So we can say list of, so this is going to be a string result list. And so here we need to add the 2 combinations we made, and the 2 combinations for this given index is like, let's say we have 0, 0, 0, 0, is basically changing this to a 1 or changing it to a 9. We need to add both of those. So it's going to be the rest of the string, and then the cur index will either be bigger or smaller. That's the change. So we can say result add, and this is going to be, let's see, this combination, so substring from 0 to I plus, so now we have to convert the character back, by the way. So if we want to convert a 9 to a 9, what we need to actually do here is we need to, this is basically going to be 0, the ASCII value for 0 plus our current value. So it's going to be like this. And then we need to cast that back to a character. So that's what we're going to do. So we're going to say character. And then this part needs to be the ASCII value for 0 plus our bigger or smaller. So let's use bigger first, plus the rest of the string, which is just combination, substring, every character after this one. So that'll be like this. So that's the bigger one. And then when you can do the smaller one, which is like the same thing, but now we just use smaller. And finally, we return our thing. And so this is kind of like the most annoying part of this problem, honestly, like getting all the combinations. So, okay, and now we can even test it. So we can actually just literally test it. So if we do like a print here, combinations of 0, 0, 0, 0, and just return 0 for now. So, yeah. Let's see what happens if we do that. Interface something. Oh, so this combinations needs to be in the actual thing. Yeah. So this needs to be in this function, or in this class. So let's do that. Let's put it in here. So this is like, I don't know why this is even here, I guess. Or this is, okay, there we go. So this is this first thing, this needs to be in here. Now it should be fine, I think. Okay, so here's what we have. So this 0, 0, 0, 0 gives us all our 8 combinations, which is exactly correct. So now the rest of it is going to be a lot easier. So let's full screen again. So essentially now what we need to do is we need to say, so here we can return -1 as a default instead if we didn't find anything. But let's see if this is this. Oh, it's because this needed to be here, like that. Okay, so basically what we need to do is we need to go through all of the combinations created here. So we can say like for string child in combinations of our current thing. So our current thing is just item com. We need to check if it's been visited already, and if it has been visited, we don't need to add it to the queue. So if not visited contains child, then we can add it to the queue and add it to the BFS. So visited add child and BFS add. So I think I talked about this before. So in a BFS, add actually adds to the back and push adds to the front. I think you can also use these two, add first, add last, and that kind of makes it more clear what's going on, I believe. So you can do add last instead, which will add to the front, to the end, and then add first will add to the front, I believe. So let's try it. So we'll do add last, so it's kind of like more clear. And what we're going to add is so we need to make a new pair of, so new pair, right, because it's like our tuple, so integer string. And the constructor will be our old number of moves plus 1, right, because we basically took our old combination and then we made one move. So this shouldn't be moves, this should be item moves. And the other thing should be the string. So this is just child. Okay. So pretty straightforward BFS with like a tuple. And this is how you do it, and you can make like custom stuff here if you want to for this. You can probably make a generic, I haven't looked into it as well, you can probably make a generic tuple with actual iterating and indexing and stuff. I haven't looked at how to do that yet, but maybe I'll do it in the future. It's all that stuff's like easier in Python, I guess. So then, so essentially what you're saying is like, okay, for all of my combinations, if I haven't visited yet, I'll add it to visited, I'll add it to my BFS, and then the number of moves it took to go from my current number to the one that I made is just 1. I only changed one number, right? Because this gives you all 8 combinations that you get from changing one number, either up or down 1. And then if I wasn't able to find anything in my BFS, then I just return -1 because like the BFS failed. So let's see what happens. Oh, we got a wrong answer. Okay, so we got a -1, so let's just double check all this, I guess. Okay, so I think what our issue actually is, and this is easy to screw up in Java, so you can't do string comparison with equals because it checks like if it's in the same location, so you have to do dot equals. So I think that's why it's never saying it's equals, because it's a different string. So let's try this. Okay, there we go. Yeah, so does it work? I don't know, I'm getting this error, but whatever, ignore it. So as far as the time, basically you put in all the dead ends, which is like less than the length, like less than the total combinations you can have. And then you basically go through all the combinations possible, and this is like, you can say is like O of 1 because it can only give you 8. But essentially, worst case scenario, you'll visit every single combination in your BFS. This is like O of 10 to the, I guess you can call it like dead ends length. So like dead ends length or something like that. And space is the same because you can have all those combinations in your visited set. So 10 of the dead ends length. Something like that. But yeah, it's going to be all for this one. So definitely a lot of code, and maybe I can have done some of these things better. So definitely if you have some suggestions, let me know about that. But yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.